Hi guys, welcome to Telecommunication Academy, your one-stop channel insofar as telecommunication is concerned. In the following series of videos, we'll be looking at Gpon technology. That's the network devices, ranging, dynamic bandwidth assignment, the frame, to name but just few. If you are enjoying the videos we are giving you, don't forget to like and to subscribe. In this first video, we are going to add introduction to Gpon technology. Enjoy it. As usual, my name is Moshen Marufu, and for any communication, my email address, moshenmarufu68@gmail.com. If you've got any comments, any disagreements, any suggestions, don't forget to get in touch with me. First things first, we want to explore the technology, and this is our aim, so that you guys develop a solid understanding of the technology, the network devices involved, how it is configured in the OLT and in the CPE, and the network impairments. And for those employed, this is to enable you to deliver quality of service requirements to valued customers. And for those at college or university, you'll be able to describe how it operates, the functions of each network device involved, and never mind the configurations, but you must know the impairments. So this is going to give you an edge in so far as your curriculum is concerned. Let's enjoy. In this slide, we are going to look at objectives, and these are our objectives. You should be able to describe the characteristic of optical fiber as a transmission line. And number 2, differentiate Gpon from other passive optical network flavors. Number 3, you must be able to outline the network devices that are found on a Gpon network and the function of Gpon modems, and also in the OLT according to in engineering, there is a way of representing large and small values, and we are going to briefly look at that. So we are saying we've got value, the recommended prefix, and the symbol. The length, never mind about this. And also, this is important. For example, deca, which is a value of 10, and it's called deca. This is the symbol that you use, and this is the frequency. 10 to the power 2 gives us a value of 100, and we call this hecto, and the symbol is small letter h, and this is how you represent the frequency of this value. 10 to the power 3 is 1000, and the prefix for this is kilo. The symbol is capital letter K. The length will be in kilometers, and in frequency it's kilohertz. So 1000 hertz is in short represented as 1 kilohertz. 10 to the power 6 has got a value of 1 million. In engineering notation, or the prefix for 1 million is mega. The symbol is a capital letter M. For example, 1 megabits per second. This is the symbol. Please take note, this is a capital capital letter M, this is capital letter K. And in frequency, 1 million hertz is 1 megahertz. 10 to the power 9, that's 1 billion, and the symbol is, so 10 to the power 9 is 1 gig. This is, the symbol is giga, but in short we refer to as gig. For example, 1 gigabit per second. The symbol is capital letter G, and the frequency is gigahertz. You know hertz, this was a guy who made some discoveries or some notable searches. So 1 billion hertz is equivalent to 1 gigahertz. Then we've got what we call tera. Tera is a value of 10 to the power 12, and the symbol is capital letter T, and this is how you represent the frequency in terahertz. Guys, this is important. If you are required to make some calculations and you don't remember that, for example, 2 gigahertz is 2 times 10 to the power 9, you don't get the answer correct. Some people confuse the 2 mega and giga, so take note of this large value representation. It's very important. Because we looked at large value representation, in this slide we are going to look at small value representation, and we are going to look at the mostly common used value. 10 to the power 3 is 0.01 in the decimal, or this, if we remove the negative power, is the same as 1 divided by 10 to the power 3, which is the same as 1 over 1000, and this is called milli, symbol small letter M. 10 to the power minus 6 is equal to 1 times 10 to the power 6, which is close to 1 over 1 million, and that value is called micro. Symbol is mu, for example. Meters, in the symbol is micrometer, for example. So this is commonly used in engineering notation. Nano is 10 to the power minus 9, which is 1 over 1 billion. The symbol is small letter n, and for example, you can have nanometers as the length in meters. Pico is equal to 10 to the power minus 12. The symbol is small letter P. It's going to be picofarads, for example, and in meters, that's picometers. These are rarely used. At 10 to the power 15, it's called femto, symbol small letter F, femtometer, it's the length. Then 10 to the power 18 is called atto, symbol small letter A, and attometers, that's in length. So small value representation, but insofar as Gpon is concerned, we'll be looking at large value presentation. We are going deeper and deeper, and in this slide we are going to show a typical Gpon network and the terminology that is commonly used. This is called the king of the network, OLT, stands for optical line terminal. This is where a fiber from the passive optical network, this is where it terminates, and it normally terminates on a Gpon interface card. So if you go onto an OLT, you must be able to pick a Gpon interface card. So this is one device you find on a Gpon network. This is a splitter. We've got one fiber incoming and various types of fiber coming out of the splitter. So this is a splitter, and it can be 1:32, 1:64, and we are now moving towards 1:128. You can have two splitters connected as shown, from one splitter to another splitter. We are going to look at advantages of each and the disadvantages of each. Then from the splitter, we are going to connect to an ONU, optical network unit. Some academics refer to this as ONT, optical network terminal. Then from there, that's where now we are going to connect some subscribers' devices. They can connect wirelessly or via some Ethernet cables. So this is a typical Gpon network. So PON is from this end to this end, from the OLT to the ONU. Then all this is referred to as the access network. Please take note the difference between PON and ODN. ODN does not include these two, the ONU and the OLT, but PON include the two. So optical network unit, optical distribution network. This does not stand for outdoor network. Please take note passive optical network, optical line terminal, virtual local area network, VoIP, this TDMA, time division mode access, point-to-point protocol over Ethernet. We looked at this in more detail in our ADSL technology course. Then International Telecommunication Union Telecommunication. This T stands for telecommunication. Then fiber to the X. Fiber to the X. It can be fiber to the home, fiber to the building, fiber to the cable, to name but just a few. And guys, take note of the fiber from the OLT to the ONU is called drop fiber. Then the fiber from the OLT splitter is called an optical trunk line, DTL. So there is bi-directional communication there. We are using one fiber and we are going to look at the advantage of this. So we are saying there is bi-directional communication between the OLT and the splitter. How do we do that? We use WDM. So this is an optical splitter. Then the direction from the OLT to the ONU is called downstream, while the direction from the ONT to the OLT is called upstream. Let us through some new important terms. Gpon stands for Gigabit Capable Passive Optical Network, meaning that the speeds are in the gigabit range. That's 1 billion bits per second. Symmetrical simply means that the upload and download speeds are the same, and when they are not the same, call it asymmetric. This is a transmission line that carries our signal in the form of light. It is made up of glass or it can be plastic. When we join two pieces of fiber, we call it splicing. Gigabit has got a value of 1 billion. Baseband in unmodulated signal. A splitter has got one input fiber and many output fibers. Input power is split equally among the output fibers. Modulate is when you superimpose an wanted signal on a high frequency carrier. Multiplexing, this is when several signals from several sources are sent through one line, and when we separate the various signals from one line to various outputs, we call it demultiplexing. Modem simply means modulation, demodulation, or an always-on connection is needed for dialing from the OLT, in this case, to the ONU downstream. The opposite is called up. The device made up of the transmitter and the receiver, a filter. As you are separating two signals, appreciate key. This is password on a CPE, wireless fidelity, ONT, another name for ONU, optical network terminal or optical network unit. If it is ONU, username, password, AAA safer. This is for authentication, authorization, and accounting. It's a safer optical line terminal. Wavelength, that's C over or V over F, visual channel identifier, visual path identifier, a link, a connection between 2 points. A port, wavelength division, multiplexing. This is the multiplexing technique used on the Gpon network. 1 to 0 is called broadcast convergence. We are having one transmission line carrying all signals. Then voice, video, and data is called triple play. Time division, multiple access. We are going to look at it in more detail. A split ratio on a splitter can be 1:64, meaning 1 incoming and 64 outgoing. This is not a new term. Internet protocol is not a new term. It's called an IP address. Then network address translation. This is a router, a device found on a computer network. It has got several functions. Fiber to the X. Ranging, we want to find the distance of ONU from the OLT. Gbps stands for dynamic bandwidth assignment. We will look at transmission containers, T-con, in more detail. Saves profile, line profile. These are configured in the OLT. This is a repeated stage. Then we are going to look at GEM ports, GEM frame, passive optical network for PON, optical distribution network. We are going to look at it in more detail in slide. We've got some network devices found on an ADSL network, and the first one is we are going to look at is called an optical line terminal. This it contains various types of cards, the control cards, the Gpon interface card. And normally the OLT is found at the exchange, also known as the central office. And an OLT serves more than one pawn, meaning that on a Gpon interface card, each port is a separate pawn. And from the Gpon interface card, we've got one fiber that connects to an optical power splitter. And from the splitter, we've got a separate drop fiber which connects to every subscriber connected onto our Gpon network. This fiber terminates on an optical network unit. This is also known as optical network terminal, ONT. So we are saying this ONU has various kinds of services that it provides to a subscriber. A subscriber can connect using Ethernet cable, or it can connect using Wi-Fi. So we are saying one fiber, a single fiber connection is used for bidirectional communication. How is that possible? By wavelength division multiplexing. So we are saying, let's leave this for another day. We are going to look at how bidirectional communication is executed on a Gpon network using WDM. What basically is a PON? A PON stands for Passive Optical Network. From this name, you can deduce that it runs on optic fiber. So we are saying this is a kind of passive optical network that features one-to-many architecture. And it consists of the OLT, ONT, the splitter, as well as the fiber. That's which connects the OLT, the ONT, and the splitter. So Gigabit capable passive optical network. Take note that when we say Gpon, this word is silent, but in full, Gpon stands for Gigabit capable passive optical network. This simply means that the network is able to operate at gigabits speed. So please take note that capable means the network has the ability to operate at gigabits speed. So take note of the difference between PON and optical distribution network. They are not the same. You might be given a network like this and you are asked to label which is the PON, which is the ODN, which is the ONU, which is the splitter, and which is the OLT. So please take note of that. It's important. Gpon technology architectures. So we are saying we've got two basic fiber to the home topologies, or fiber to the X topologies, and we are saying we've got 0.2. So we are saying this device is connected directly to these CPEs, which means that the communication going on between these two is different from communication going on between these two. The signal on this line is different from the signal on this line. So we call that 0.2 point. In our case, from the OLT to the CPE, we are calling it the transmit direction. Then from this to this, the receive direction. And we are saying the split ratio there, there's no splitting, it's simply 1:1. Then we've got 0.2 multi-point, or one-to-many. In other words, we've got one fiber from the OLT to the splitter, then various types of drop fibers from the splitter to the respective subscribers. So this is the picture of a splitter. One incoming, many outgoing. And the split ratio, for example, it can be 1:64, meaning one incoming fiber is going to have its power splitted to 64 drop fibers equally. But we are now moving towards 1:128, meaning one incoming fiber is going to have its power splitted equally to 128 drop fibers. Please take note of the two FTTH topologies or architectures, point to point, meaning this is a point and this is a point. This is another point, and this each has got a separate fiber to the aggregator. Whereas on point to multi-point, while each subscriber is connected to the splitter by an individual drop fiber, from the splitter to the OLT, we have got only one fiber. So we are going to have a look at how communication is possible on one fiber in both directions at the same time. Direction from the CPE to the OLT is called the upstream direction, and 1310 is nanometers. This is the wavelength used in the upstream direction. In the downstream direction from the OLT to the CPE or to the ONT, we are going to use a wavelength of 1410 nanometers, and this direction is called the downstream direction. Then the advantage of this is we use less space, less deployment of fibers, and because we've got one fiber running between the OLT and this splitter, it means we can afford to use less smaller ducts. Physical layer operation of a Gpon network. You remember the OSI 7 layers. So we are looking at the physical layer operation. So we are saying we've got an OLT at the central office or exchange, and we've got a number of views in our network. So we are saying the power from the OLT in the downstream direction is split at each branching point at the splitter. So we are saying the power is split equally among each drop fiber or branch. And what are we saying? We are saying a splitter is a point of power loss, but what is its advantage? We are going to have less deployment of fiber on our network. So, and please take note of this important point. The splitting of power is the same, or the loss of power is the same in the upstream direction and downstream direction. We are saying if we've got a 3 dB loss in the downstream direction, we also have a 3 dB loss in the upstream direction, hence the word symmetry. Its loss upstream is the same as in the downstream, and we've got a 3 dB loss for each power of 2. We are going to have a look at this in one of our lecture presentation. So we are saying our OLT transmits a continuous downstream signal that conveys, we've got a timing signal, control signal, a management signal, and payload. What do we mean by payload? This is the information that is sent. All this timing, control, and management enable us to have effective transmission of signals in each direction. And please take note that the OLT is the most important and expensive device on a passive optical. This is the question that most of you must be happening. Why Gpon? We have got ADSL. Why do you think Gpon is important or is being deployed or is replacing ADSL technology? And let's have a look at this. So we are saying Gpon supports this type of service, the triple play service, and it provides competitive all service solution. We are saying voice, video, and data at high speeds, not just speeds, at high speeds. It also supports, because it uses a backbone of optical fiber, and among all the transmission mediums, the signal with the highest fiber, because it uses light, is optical fiber. So we are saying Gpon supports high bandwidth transmission, thereby it breaks the bandwidth limitation or bottleneck of UTP so that it is able to satisfy the requirements of high bandwidth services such as IPTV as well as live TV broadcasts. So it has got an unlimited bandwidth. It can only be limited by equipment. So we are saying in terms of reach, Gpon supports up to 20 kilometers. It supports up to 20 kilometers service coverage. So it is able to overcome the various obstacles of access technology when compared to UTP. In terms of standardization, we are saying Gpon has complete standards and high technical requirements, meaning Gpon supports integrated services in a very good way. In one of the slides ahead, we are going to look at the Gpon standards. So we are saying because of these reasons, high standards, its long reach, high bandwidth, and all service solution, Gpon is therefore a technology of choice for large carriers. Pon standards, we've got EPON, Gpon, 10G EPON, XG, PON, time wavelength, vision multiplexing, PON, point-to-point, WPON. And we are going to concentrate on this, which is our Gpon. We are saying the typical standards or the standard used on Gpon is called ITU-T G.984. ITU-T is International Telecommunication Union responsible for telecommunication. We also have ITU-R and ITU-D. So the ITU-T standard is G.984. Then the downstream speed of these standards or of Gpon is 2.5 gigabits per second in the downstream direction and 1.25 gigabits per second in the upstream direction. Then the line coding technique that is used on Gpon is called non-return to zero. We've got a lot of line coding techniques, so we are going to use non-return to zero. The responsibility or the function of line coding is want to make sure that the signal from our devices adapts to the characteristic of our transmission line, which is our optical fiber. Then in terms of differential reach or logical reach is 60/20 kilometers. 20 is for physical reach and 60 is for logical reach. We don't consider losses, and for it to stretch up to 20 kilometers, this is less than this because on the physical reach we consider losses. Then in terms of splitting ratio, 9.G.9824 uses a split ratio of 1:64. Then in terms of encapsulation methods, we use GEM. Then in terms of ODN compatibility, yes, it's compatible. Then in terms of cost, Gpon is low, and in terms of maturity, because it has been around for a while now, maturity is high. These are the services that can be provided by a Gpon network, and this is what we mean by triple play: voice, video, and data. Please take note that there's no mobility on Gpon. There's no mobility, but it supports triple play: voice, video, and data from the core network onto the master of the PON, which is the OLT, optical line terminal. Then from there we are going to have our trunk fiber, which is going to connect one Gpon interface card to the splitter. And so we are saying from the OLT to tap, that's our ODN. Post simply means passive optical splitter. Then our drop fiber from the splitter to the respective ONUs. So we are going to have the incoming power being split equally in the or between rather the outgoing fibers. So this is a point of power loss, and the higher the splitting ratio, the more the loss, and it is by the loss is symmetrical, which means it is the same in the upstream direction as well as in the upstream direction. So these simply represent some splitters. So we have cascaded these two splitters. Normally it's only one splitter on a passive optical network. So the OLT, please take note of the representation of PON and ONUs, and we are saying OLT, optical line terminal, ONU, optical network unit, ONT, optical network terminal, then ODN, optical distribution network. Optical distribution network does not include the OLT and the ONU. And we are saying this is P2MP, point 2 multi point, 1 point to these multi points. This is just a summary of the diagram on the previous slide. So that we had two devices that need power for them to operate. That's the OLT, which is normally found at the head end. And we've got the customer's premises equipment, and it is known by following names. Some call it the network interface device, NID, while some call it the optical network terminal, ONT, and others call it the optical network unit, ONU. So these, they refer to equipment found at the cyber premises. So we are saying of all the three, usage is tending towards the use of ONU. So this is now accepted as the preferred term for the equipment found at the subscriber's place. So ONT and ONU are used. Those names are used interchangeably, and also network interface device. Feeder cable, distribution cable, as well as the drop cable. And please take note of the following terminology. POP stands for point of presence. That's where we find the OLT. Then one fiber from the OLT to the splitter, and it can stretch for 3 to 5 kilometers. Mind you, we said the physical reach of Gpon can be up to 20 kilometers. Then from the NAP, this represents network access point. It can stretch from 2 to 3 kilometers, and then from there, from the NAP to the customer's place, normally less than 100 meters. So we are saying we don't need power in the ODN. There's no need for power, hence it is referred to as a passive optical network. The OLT must be powered, hence this network is active, and the ONU or the ONT, the network interface device, must be powered, hence active. So the cable from the OLT to the splitter, we are calling it the primary cable or the feeder. Then from the OLT to the network access point, we are calling it the drop fiber. Then between the splitter and the NAP, the network access point, we are calling it the distribution cable, also known as the secondary cable. If this was an ADSL network, we would call this the cabinet, the exchange, and the distribution point. Please take note that we can have the network access point being connected directly to the OLT, hence this we have got from the OLT to the NAP, from the NAP to another NAP. It can PON operation. We have got this question: how does PON work? In one of the slides, we said it uses wavelength division multiplexing. In other words, that means FDM, because in optical fiber communication, we don't talk of frequency, rather we talk of wavelength, hence the term wavelength division multiplexing. So we are saying for us to have bidirectional communication on this trunk fiber in the downstream direction, guys, take note that with this, according to G.984, it uses a speed of 2.5 gigabits per second, hence it's thicker than this, which uses a speed of 1.5 gigabits per second. You remember the values, gigabit 10 to the power 9. We are saying the downstream speed is higher than the upstream speed. This is representing the splitting function, and in this direction we find the OLT, optical line termination, and in this direction we find ONT, optical network termination, or ONU. So we are saying in the downstream operation is called, or the packets are transmitted rather in a broadcast manner, which means in the downstream direction each ONT receives the same amount of packets from the OLT. So it uses a type of addressing to identify the packets that are addressed to it, but each ONU or ONT receives the same amount of packets, hence 1 to all, which is meant by broadcasting. And the wavelength that is used in the downstream direction is 1490 nanometers. You remember nano, which was a smaller value representation. So that's the ODN. ODN does not include the OLT, and neither does it include the ONT, but PON include this. It stretches from the OLT to the ONT in the downstream direction. Let's have a look at passive optical network operation in the upstream direction. So we are saying it operates in a time division mode access manner, which means that only one ONT can transmit at a time. Please take note that each pawn is connected to one laser at the Gpon interface card. There is one laser. In other words, there is one receiver, meaning that only one ONT can transmit at a particular time to avoid collision in the trunk fiber or in the fiber between the OLT and between the splitter and the OLT. So we are saying the transmission mode used in the upstream direction is TDMA. So take note that we've got various computers each connected, or these are various subscribers, meaning various computers or different commuters connected. This is an ONU. So each subscriber is connected to a different ONU. Then from there we are going to connect to the splitter. This is a splitter and this is the OLT. But in this fiber, we must have only data from one ONT. Because if we have data from different ONUs being transmitted in this trunk fiber between the OLT and the splitter, we are going to have collision. Remember, collision in sigma CD. So the wavelength used in the downstream direction is 1390 nanometers. You remember small value representation, that's 10 to the power minus 9. So in the upstream direction, TDMA manner, in the downstream direction, broadcast manner. That's how Gpon operates in the downstream and upstream direction. Please, a review questions from the last two slides. Number one, the direction of transmission mark A. This red arrow there is labeled A. What's the transmission mode used in this direction? And the direction marked D. We saw that in this direction is called the broadcast manner, and in this direction is called TDMA manner. Okay, can you attempt the remaining questions? I think I responded to this question during the lecture that normally this one is thicker than this, and there's a reason why arrow mark A is thicker than arrow mark B. Please take note that you must know the wavelength in the direction level A and the wavelength in the direction level B, and this is all covered in the last two slides. Then we are to cover this, so leave this question until we have attempted the presentation on dynamic bandwidth assignment. And normally it is implemented in the upstream direction, and there is a reason for that. Guys, I hope you have enjoyed this introductory presentation on Gpon, whereby we looked at the network elements involved, operation in the downstream direction and upstream direction, PON, ODN, the feeders, distribution fibers, the drop fibers, etc., etc. Let's meet in our next presentation. Otherwise, if you are enjoying, don't forget to like, to comment, and also to subscribe. Bye bye for now.